Okay guys, so welcome to my fundamental chemistry class. For those preparing for WAEC, JAMB, NECO, and then for chemistry teachers that want to improve on their technical competence, and then the class covers both theory and then practical. Okay, so let's treat some questions. Our first question for today says, which of the noble gases has the greatest ionization energy? You know, when you study the periodicity of elements, periodicity is the recurrence of similar phenomena at regular intervals. So you look at the melting and boiling points, electrical and thermal conductivities, ionization energy and electron affinity, and electronegativity. You know, when you are looking at these properties, what you should focus your attention is how does the property varies across the period and down the group. For example, this question that is talking about ionization energy. You know, first ionization energy is the energy of an element to remove the outermost electron. Okay, so and then as a rule, ionization energy increases from left to right across the periodic table. So you have to go back to periodic table, study everything, like get familiarized with all the elements on the periodic table and their positions. You understand? So if we look from left to right, you know, the leftmost element is hydrogen, and then if you now come down from the hydrogen, you have lithium down to sodium and potassium. Now if we stay at lithium, that's period 1 is hydrogen and helium, period 2 is where lithium starts. So if we move from lithium, that is from our left, we have lithium, we now get to the right where it terminates at beryllium. Okay, then if you look at the first period, we have hydrogen and helium. So as a rule, ionization energy increases from left to right. That means, and then decreases from down. That is, it decreases down the period, decreases down the group, increases across the period. You understand? So all these elements here are in group 0 or group 8, which are the noble gases. So if we come down, the first element on that group 0 is helium, and it's at the extreme right. That means it has the greatest ionization energy. You understand? It has the extreme right, it has the greatest ionization energy. So when you now come down the group, the ionization energy will increase. So the correct answer is A, helium, because it's at the extreme right. You know, factors that affect ionization energy, I think there are about 3 of them. We talk of the distance of the outermost electron from the nucleus. We talk of the size of the positive nuclear charge. We talk of the screening effect. You know, helium has just one shell, you understand, which is the K shell, and that shell is closer. This is another explanation to why helium has the highest ionization energy. That shell, that K shell, is the closest to the nucleus. You understand? So the attractive force, the attractive force between the nucleus and that K shell is very high. So it will take more energy to remove the helium outermost electron. You understand? So that makes helium to have the highest ionization energy. Okay, the second question says the weakest attractive force that can be observed between 2 molecules is. So all these are examples of attractive forces. Ionic, example of ionic compounds is sodium chloride. Ionic compound has to do with transfer of electron from the positive, the electropositive element, which is the electron donor, to the electronegative element, which is the electron acceptor. So those ionic compounds, they have high melting point, they have high boiling point, and then you come to covalent. Covalent compounds are compounds that occur by sharing of electron, like chlorine gas. Okay, then coordinate covalent is a covalent bond that has accepted an extra electron, okay. So for example, or donated an extra electron, for example, ammonium ion. Okay, then van der Waals force is the answer. Is the weakest attractive force. The weakest attractive force. You have van der Waals force in substances like camphor, and then ammonium chloride, and so all substances that have van der Waals forces tend to sublime. Sublimation has to do with changing of substances from solid to gaseous state without passing through liquid state. Okay, so D is the correct answer. Okay, the third question says an element that is used in the production of matches is the answer is sulfur. Sulfur is one element that can burn with great heat. I think that's what I think that should be why the Christians believe that the hellfire would be a fire that is made with sulfur and brimstone. So the answer there is sulfur. Okay, so the next question says cathode ray. Next question says cathode ray cause an object placed behind a perforated anode to cast shadow on the screen. The observation shows that cathode ray is now for something to cast shadow. Now let's get straight. The answer is D. You understand? The cathode ray travels in a straight line. In physics talks about rectilinear propagation of light. Rectilinear propagation, it believes that a light travels in straight line. So waves that travel in straight line, they tend to cast shadow when they meet obstacle like light. So for cathode ray to cast shadow, it means that it travels in straight line. So D is the correct answer. Okay, the next question says the flow of current in electrolysis is due to movement of electrons. Where is it? So option A is the correct answer, movement of electrons. Okay, this B says holds an electron. This holds an electron is mostly applicable in how do you call it, electronics. But for this question, the answer is electrons. Okay, let's check the next question. It says a suitable reagent for distinguishing between ethanoic acid and ethanol. Now you should be able to understand these substances and then perhaps identify them around you. Now ethanoic acid is vinegar, it's especially the white vinegar, while ethanol is our ogogoro or kaikai, as people may call it. Okay, so the reagent that can distinguish the two of them is D option, C option, sodium hydrogen trioxocarbonate. This sodium hydrogen trioxocarbonate, this is a popular baking powder. You understand? Sodium hydrogen trioxocarbonate is baking powder. So since it has a carbonate, CO3, now when you drop any acid on it, it will liberate carbon dioxide. So when you drop ethanoic acid on this trioxocarbonate, it will liberate carbon dioxide. But when you drop ethanol, since ethanol is not an acid, it's not going to give you the carbon dioxide. So that will now be a distinguishing factor to tell which one is ethanoic acid and which one is ethanol, because both of them have white color, or they are colorless in appearance. Bromine water is used to test for unsaturation. That's decolorization of bromine water by a double bond and triple bond compounds. Then failing solution. Failing solution is used for reducing sugar test. Okay, then the next question says, in the discovery of proton, sorry, that's proton, not protein. In the discovery of proton, the instrument used is the option D, which is discharge tube with central cathode. You know, that's the instrument that is used to produce both cathode ray and positive rays. You know, that's the instrument that was used by J.J. Thomson in 1897 to discover both the electrons and the protons. You know, like if you could remember, it was in 1808 that John Dalton first discovered the atom, and then he told the world that atoms were indivisible, until some other scientists have to come and probe further and discover that atoms were actually made up of subparticles, which like electron, proton, and neutron. So J.J. Thomson was one of them that discovered those subparticles. So he single-handedly discovered proton and then electron using this discharge tube with central cathode. Okay, the next question says the orbital diagram. Okay, so sorry that the diagram is not displayed, but it was actually referring to the diagram for nitrogen. So you should be able to get the diagram, at least the first 20 elements, diagram of the first 20 elements. Okay, so you now take note of the shell electronic configuration and the orbital electronic configuration for those first 20 elements. Okay, so like nitrogen has atomic number of 7. Okay, so if you break it into shell configuration, you are going to have 2,5. That's the K shell takes 2, the L shell takes 5. Okay, then if you break it into orbital configuration, you're going to have 1s2, 2s2, and then 2p3. Okay, next question says, which of the following metals burn with a brick red? In qualitative analysis, you should be able to identify color of substances. So the correct answer here is B, calcium. Calcium burns with calcium ion burns with brick red color. Copper ion burns with deep green color. Lead ion burns with blue. Sodium ion burns with persistent golden yellow color. Potassium ion burns with persistent lilac color, while barium ion burns with persistent light green color. So you should be able to take note of all that. Okay, the last question for now says in the production of soap, concentrated sodium chloride solution is added to. Now that stage is called salting out. You know, in high school chemistry like this, we call it saponification, where either fat or oil reacts with alkali. The alkali could be caustic soda, that's sodium hydroxide, or potassium hydroxide. You understand? So by the time that reaction occurs, two products are formed, which are the soap and glycerol. So to separate the glycerol from the soap, you now add sodium chloride, concentrated sodium chloride. You understand? That process is called salting out. So what the sodium chloride does is to decrease the solubility of the soap. You understand? So it will now make the soap to float out, to float up, and then you now separate it from the glycerol. Okay, so we stop there for now. Feel free to send in your questions, your contributions, so that we continue to help you the more. All right, so thank you so much, and then you are free to schedule Zoom class on chemistry, or pay a visit to my technical center here in Eked for physical class. We also do chemical consultancy, environmental impact assessments, remediation, soap and detergents production, and then a wide range of chemical products and consultancy. All right, thank you and bye bye.